Hello, I hope you're well. We have a question here on strength of materials, and it reads: a solid circular shaft of diameter d transmits a torque T. Show that the maximum shear stress tau in the shaft is given by tau equals to 16T over pi d cubed. So we are going to follow the following steps, step by step, and I hope it is going to be very much helpful to you. So let's consider this circle here, assuming that this is a cross-section of the shaft, or the circular section of the shaft that we are talking about, which is solid. Actually, it is not tubular. What I'm demonstrating here is that we are going to consider this strip, which has got a thickness dr, and the radius of this circle or this section is r, and the small radius as shown here is r, small r. So we are going to consider this, and we are going to start step by step so that we may be able to solve this finally, to prove that tau equals to 16T over pi d cubed. We will start by determining the area of the strip as shown here. Actually, the best way I can explain this is that we already know that this strip, when it is cut and made lengthwise, it is going to make a rectangle section, whereby to get the area or to get the length of all that rectangle is going to be 2 pi r. So we are going to say, first, getting the area of the strip equals to 2 pi r times the thickness is going to be the height of that portion, so it will be 2 pi r dr. So that will be the area of that strip. Next, let's get the shear stress on that portion. So we are going to say shear stress will be equal to tau due to r, that is the section r, times r over this capital R here. Next, we are going to determine the turning force. So we will say turning force equals to the shear stress turning force equals to the shear stress, which we have here, shear stress times times the area of the strip. So it will be, turning force will be equal to the shear stress times area of the strip. So we will be inserting the values here. The shear stress is tau r times r over r here, multiplied by 2 pi, sorry, this pi of mine here is a little bit fun, 2 pi r times dr. When we multiply here, you'll find that we get tau r. We have r here, we have r here, so it is going to be okay, sorry, let's write it correctly here. It is going to be 2 pi tau, then here we have r squared dr all over R here. Now to get the torque, we need to get the torque here. It will be equal to the turning force times the perpendicular distance. Let me say distance here to be precise. So here we will be having the turning force, which is 2 pi tau r squared over r times dr. Then we multiply by the distance here, which is r. So we're going to get a total here of 2 pi tau r cubed over r dr here. Now to find or to get the total torque transmitted here, so to find the total torque, we are going to integrate this equation here between the limits capital R and 0. So we are going to say we integrate this between R and 0, where we have 2 pi tau r cubed dr over r. But here we are having our limits, so we are going to we have constants here, 2 pi tau over r. These are constants, so we are going to take them outside of the integration. Then we integrate r cubed dr with respect as we stated here. So we take out the constants. We are going to have 2 pi tau over r integral of r cubed dr. So here we are going to have 2 pi tau over r multiplied by, here when we integrate this, we are going to get r power 4 over 4. Here we have r 0. So this is going to be 2 pi tau over r multiplied by, so this one is going to be r power 4 over 4. I hope we understand how we integrate. We normally add 1 here, then we divide by the same answer we get here. So it is going to be r power 4 over 4, and then to open this we are going to substitute the r with the limits we've been given. So it is going to be r power 4 divided by 4. Up to there we are going to have 2 pi tau r power 4 over 4 r, which is equal to pi tau r cubed over 2, over 2, because 2 and 2 and 4 here cancel, we remain with 2r reduces the 4 here, we are going to remain with cubed. So up to there I believe we will be sorted, but r here equals to d over 2. So here we are going to say this goes to pi tau d over 2 cubed hope you're together, over 2. This is going to be giving us pi tau d cubed. This 2 cubed is 8. 8 times 2 here we're going to have over 16. Now this is equal to the torque, total torque T. Since we've been asked to get tau, so we are going to make the making tau subject. We are going to have tau equals to, this is going to be 16t over pi d cubed, and up to there we will have solved this equation. Thank you for watching. I hope you're going to subscribe to our YouTube channel. My name is Paul.